Dear Javanturists, naše sljedeće predavanje će biti naš kolega iz vrlo bliske nam zemlje, samo tu, jutro ste doputovali, jel tako? Tako da ovoga... Radi? 1, 2, 3, radi. Radi se o profesoru Matjažu Juriču koji ima mnoge druge titule, tamo neke koje se recimo zove Java Champion. Mislim da ste vi jedini Java Champion danas na našem Javanturi. A i nema tih Java Championa baš tako jako puno u svijetu koliko bi čovjek rekao. Ali ima i mnoge druge titula, a napisao i dosta knjiga koliko sam ja to uspio vidjeti. Neke čak ja i svojim studentima preporučujem. Tako da sljedeće predavanje će biti Cloud Native Architectures and Java i evo, možda smo malo u pomaku, ali nekak ćemo to poslije stisnuti tako da otprilike znate kako će dalje ići. Matjaž, the stage is yours.
Jel me čujete? Da, dobar dan. Eto, u redu je, u redu. Eto, hvala što mogu biti ovdje. Danas ćemo govoriti o Cloud Native arhitekturama, ali moj hrvatski nije toliko dobar da bi ja sad pričao sve na hrvatskom, tako da ću ovo uraditi na engleskom. I will now switch to English. I would like to talk to you about the Cloud Native architectures. And you might have heard about the cloud and even about the cloud native architectures. And what I would like to discuss with you now in the next half an hour is basically how the cloud native architectures are different from what we are doing today. And as you will see, there are many important differences, and the cloud native architectures are basically changing not only the way how we develop software, but they are also changing some important aspects surrounding the software development, such as organization, project management, and so on. But let's start with some motivation. Now, you know that software is becoming an important factor defining how different companies differentiate each other. And we know that more and more businesses, more and more modern businesses are being run on software, and they have been delivered as online services. What I'm talking about, you all know those companies such as Uber, Alibaba, Facebook, Airbnb, and so on. Those companies have become important companies, and they actually change the way how we live, how we do business, how we actually how we live our lives, if I can say it like that. And what I'm trying to say is that basically this digitalization, the digital business or the digital transformation is actually about delivering the software and the business innovation through such software. And well, understanding this, that software is more and more becoming the key ingredient of the innovation, the software is basically becoming what differentiates companies among each other. This is actually really important. And you are probably familiar with well-known sentences such as software is eating the world, or the other sentence where for example, what I have here is an expert from a web page from CEO of Microsoft, who said that every business will become a software business. And actually, those sentences have been said exactly because software is becoming so important in today's digital business. Well, actually, the interesting thing is that even industries which have not been connected to software development are rapidly changing. What I have here is a sentence from Ford, from one of the executive directors who said that in the past 90% of the car value was in hardware, but today 50% of the car value is in hardware and 50% in the software. So even cars or even traditional businesses are becoming more and more dependent on the software. And why I'm telling you all this is because it is important to understand that such software which drives the innovation, such software usually cannot be bought, and the companies have to develop such software for their custom purposes, for their custom needs. And this is also what Gartner says actually. The Gartner forecast says that 75% of the software for supporting digital business will be built, not buy. So this means that we will have to custom develop such software for each and every company. And this will basically be all kinds of companies because, as I have mentioned before, every company is becoming a software company. And for us, for software developers, this is actually a challenge. And the challenge is how to build such software. And how to build such software faster, how to build it in a reliable way so that we have a software which is more resilient, more fault tolerant, does not break so easily, how to build software which is scalable. We are not talking about 10 or 100 or 1,000 simultaneous users, but if such a software is successful, and if a company which uses a software to do some sort of digital business is successful, then the number of users can grow exponentially. And well, maybe don't think that this is just Uber and Facebook who really need scalable software. I have been talking to some Slovenian banks, and for example, what they told me, since they have mobile banking, what the users do when there is the payday, when they get the salary, they check their account balance every few seconds from the mobile device. Yeah? This is the load on their back-end systems, which is much higher than anticipated. And often such systems have not been designed to have such load. So what I'm trying to say is that it is not just those big internet famous applications which need scalable architecture and support for elasticity, but it is also more regular software. And as we go towards the digital business, more and more companies will require this. And finally, how to build engaging software. What does this mean? How to build a software with perfect user experience. How to do applications which are Apple style, if you wish. Yeah? All those challenges are really, really important. And what we believe today, that the answer to those challenges is the cloud-native architecture. And the cloud-native architecture is actually not where to run the software. So the cloud-native architecture is nothing about packing existing applications into virtual machines and running them in a public cloud. The cloud-native architecture is about how to develop, how to build, how to architect the software so that it can fulfill those requirements and that it can use the new technologies, the new approaches in the right way. And most importantly, to simplify the software development, to make it less error-prone, more reliable, faster, and so on. And what I would like to talk in the next few minutes, I would basically like to go through the key ingredients of the cloud-native architecture. And basically, when we talk about the cloud-native architecture, we have the front-end part and the back-end part. And the transition to cloud-native on the front-end part is quite simple, going from the server-side web development to the client-side web development. And I'm pretty sure that many of you already use the client-side web development, HTML5, JavaScript, frameworks such as Angular, React, and so on, to develop front-end applications which run on the client within the web browser, or to develop the mobile applications for different platforms. So the transition on the front end is going away from servlets, Java server faces, Java server pages, PHP, ASP, and so on, all those server-side legacy technologies, and going towards the client-side web development. And once we have done this step, this also changes the way how the backend should be built. And on the backend, the changes are a little more, a little bigger, they have a wider impact actually. Those changes start with the microservices. And probably all of you have already heard for microservices. Microservices are basically the architectural approach, how to decouple the applications, how to decouple those applications into single-purpose services. And those services should be loosely coupled. Why? To be able to develop complex software faster, to being able to use cross-functional teams to develop such software, and so on and so on. Let's look at the example. Microservices, actually what they say is that instead of developing traditional applications, as you can see them on your left, you develop applications which consist out of microservices. And each microservice serves one single purpose. Those microservices are independent not only in the logical way, but they are also packed and deployed as independent units. And this is probably the most important part. We have talked about services before. You all remember service-oriented architecture and so on. But what microservices really bring is the idea of having services as standalone units which are deployed and managed individually. And what does this bring? This brings two important things. One is that we can develop software with microservices in such a way that we can develop different microservices in parallel. So no more, or I cannot say no more, but I can say much less coordination between different teams, much less communication, much less waiting for everybody to finish the source code in order to be able to build the source code and deploy the whole product and so on. But microservices also bring some important technical aspects. If the application is decoupled, if it consists of several different building blocks, it is much easier to scale such application. It is much easier to upgrade the application because you can upgrade just a single microservice, not all of them. It is much easier to upgrade the versions. Those of you who come from Java EE environments, some of you probably know what the challenge is to upgrade the app server to go to a higher version of Java EE or Java Standard Edition. You have to upgrade all the applications first and so on. What about microservices? No such hassle. You can upgrade the versions for one microservice and have the other microservices on the older versions. And once you start thinking about microservices, you can see that there are many other benefits. Suddenly, the technology choice is also not that important anymore. With microservices, you can combine different programming languages, different environments. If some services should not be written in Java, you can switch to Node.js or whatever language you wish. Microservices have some other important aspects. Some of them are, or one of those aspects are interfaces. It is really important that once we start using microservices, that each service has an explicitly defined interface. And you might say, okay, we knew that before. Yeah? Even if we develop traditional applications and we have REST services or SOAP services, we know that we need the interfaces. Yeah? But microservices foster us to use those interfaces explicitly. If you have developed a traditional JEE application, you might have a REST service. However, you might have called those classes also directly or exposed them through remote interfaces as well, and so on. And once we start talking about interfaces, actually the APIs, it is also important how we design them. And remember those loosely coupled things that I have mentioned. Microservices work well if they're loosely coupled. And today there are several approaches how to achieve loose coupling. Now, it is commonly believed that synchronous invocations and synchronous operations in the interfaces are not the right way to achieve loose coupling. And we know that REST and SOAP and all other technologies enable us to use asynchronous, even streaming APIs. And these are some aspects that might or should be considered. Later on, I will also talk about circuit breakers. Now, what else? Microservices should be designed for failure. This is another important aspect. And there has been a lot of effort put into how to develop and design the services to meet those requirements. What I have already mentioned is that microservices are actually built and deployed separately. So if we have an application which consists of microservices, such as on this example, this application would break into basically 4 or even more parts. We have 4 different microservices on the picture there. These would be 4 different independent artifacts which would need to be built and deployed. And now we deploy microservices in their own processes. This could be a virtual machine, this could also be a container. And another important feature is that we design the architecture in such a way that different versions of the same microservice can coexist, that they can run side by side. Finally, the microservices are also a way how we can scale the applications. And therefore, it is important to design microservices in a stateless way, which allows us to scale them horizontally. Now, for Java developers, in the last year, several different frameworks have emerged. Those frameworks allow us to develop microservices using standard Java or Spring framework, and basically mean that we can move from traditional JEE environments towards the serverless Java. You probably heard about the serverless Java EE, which is becoming more and more important. And well, I'm pretty sure that you are already familiar with some of those names, such as Spring Boot and Spring Cloud, which are really popular for developers who use the Spring framework. Then Wildfly Swarm, the JBoss app server, which has been redesigned in order to support microservices. Our Cumulus EE framework, which we will demonstrate later on after lunch. Drop Wizard, Pajara Micro, and so on. In the last year, a lot of effort has been put into how the microservice environment should look like. And basically what I would like to point you to is the micro profile, which is the profile for developing Java microservices. And this micro profile basically defines which technologies and in which way we should use the Java language and which Java EE APIs can be used in order to do the microservices in a portable and standardized way. What I haven't mentioned explicitly with Java is, of course, that if we do microservices using Java EE, there is always this problem of the app server. And serverless Java and those frameworks are actually solving the problem of app servers, and they allow us to develop Java EE apps, actually Java EE microservices, and pack them in a way that they don't require the app server anymore. Usually we talk about fed jars or some other kinds of packing, or as in the case of Wildfly Swarm and Pajara Micro, we talk about how to actually slim down and decompose the app server so that we don't have to, first of all, run a large app server, and that we get a lightweight execution environment in which those microservices can function as we would like to have them. Microservices are also very connected to containers. The most well-known containers are Docker containers. You know that they are not the only one, and so on. It is important to understand that microservices are not tied to the containers, but it is very helpful if we combine the microservices with the container technologies. The reason is because the containers are also lightweight as well. This is the same as microservices, and they allow us several interesting things, such as they are quick to start and stop, they are portable, and so on. You have probably already played with Docker containers or even used them for some real-world applications. How many of you have already used Docker containers? Okay, I see quite a lot of hands, which is good. Yeah. If we use the containers with microservices, we should follow some rules, actually. One of those rules is that we run only one instance per container, and that we expose only one port per container. And well, for all of you who think that the containers are just very similar to virtual machines, it is important to realize that this is actually not the case. Traditional virtual machines and containers have a lot of differences, a lot of important differences. If we combine microservices with containers, some other things change, actually. We don't think about packing artifacts, the services, into ERs, vars, or jars, but we think about how to pack the microservices into containers. And this has some implications. No more GVM, app servers, deployments, configurations, and so on. What we do, we build a container, deploy the microservice into the container, and then do some other things about the configuration, for example, through the environment variables. And if we design the containers in such a way that they are free of state and configurations, they're very portable, and they're easy to deploy, they're easy to maintain, and they bring several important positive aspects. Once we design microservices to work with containers, it is also very important that such services do not write to the local file storage. And this also has some implications to logging, which I will also discuss a little later. Now, to build those containers, we usually just declaratively build them using Docker files. If you are not familiar with that, I would suggest that you spend some time and get familiar. And once we have the containers with the microservices, we start to ask ourselves how to deploy and manage those containers. And a lot of effort today has been put into the container orchestration technologies, such as Kubernetes, Docker Swarm, Mesos, even OpenShift, and so on. And those environments actually allow us, when we combine everything from microservices, containers, and containers orchestration, we get an environment where we achieve the cloud elasticity. What does this mean? This means that we have many containers with microservices which form an application, and those containers can then be dynamically executed on different hosts that we have. And in such a way, we provide this horizontal auto-scaling and the elasticity, where each microservice is actually instantiated in so many instances as needed for a specific use case or for a specific load of the application. Let us now have a little closer look at those microservices. Now, I don't know what you really think. Maybe you think, okay, those microservices concepts, these are, well, is this something that will be real, or is this just some, you know, some hype? But the fact is that once we start to think about microservices, well, some more additional building blocks are usually required. What this figure tries to show is an application which has several different microservices. We have a client here, or different clients which access those microservices, and we have to go through different things and consider different things. The first and the most important one is how will we communicate with microservices. Will all these be just REST communications, or do we need some other way of communication? Yeah? So what we see on this figure is that we also use the messaging. Messaging is one way how to achieve asynchronous communication. It is not the only one. The other important thing is that we have to address the problem of how the clients will actually call those microservices. And particularly for mobile clients, but also for web clients, it is usually not very efficient if a web or a mobile application opens communication to several different microservices in the back end. And this is why we usually put some additional building blocks into the overall architecture. One of those building blocks are API gateways. API gateways allow us to expose microservices on one endpoint, on a single endpoint, and manage all the communication from the client side to the microservices, but also within microservices, yeah? And do some additional things such as security, metering, logging, and so on. Then what we have to address is identity and access management. If you have already tried the client-side web development, you know that we have to authenticate on the client side. And once we authenticate on the client side, things also change. No more server-side or container authentication, but we need to propagate those authentication to the back end. What we talk about are usually authentication servers which support OAuth 2 or OpenID or some other form of modern authentication. And for example, a good example of an open source authentication server is Keycloak, which allows us to manage all different authentications, particularly when we want to federate this with older JEE applications. Another important aspect, service discovery. Now, if we have a relatively simple topology and a few microservices, it can be the case that we will know the URLs of each individual microservice. But what do you want to put those URLs into the client? If you have done some HTML5 applications or mobile applications, have you coded the URLs to your REST services into your client-side application or not? Yeah. Now, service discovery can solve those problems. Yeah? And service discovery is also related to the configuration servers. So once we start talking about microservices, one of the challenges is where to put the configuration. Yeah? The basic approach how to solve the configuration problems is to use the environment variables. But the environment variables require that if you change the configuration, you restart your service or the whole container. So today, the configuration servers, which are sometimes combined with service discovery, are more often used. About service discovery, well, if you want to talk about concrete products, there are several of them Eureka, Zookeeper, ECTD, and so on. There are several service discovery and configuration servers as well. And then another thing that we have to solve is the logging problem. So basically, how to do the logging. Now imagine that you have several microservices, each microservice in its own Docker container. How do we want to do the logging? It is not enough to log on the file system anymore. You have to be able to collect all those logs, have it in one place in order to follow and analyze them. I'm running a little bit out of time, so I will go just quickly through those aspects. I have mentioned APIs and API gateways, although we could talk more and more about that. I have mentioned how to change the loggings and what changes in the logging are required. And then there's another thing, the circuit breakers. Now, microservices drive us towards the distributed architecture. If your application consists out of microservices, those microservices will be in different containers. Those containers will maybe be managed by Kubernetes, so you will not really know where those services are. And it could happen that a service is not available for a certain amount of time. Now, circuit breakers are frameworks which address the problems of invoking microservices. Now, if there is a failure in the invocation path, the circuit breakers will prevent the cascading exceptions. And this is also quite important. One of the most well-known frameworks for this is Hystrix framework. Another important thing which you should consider is the database per service pattern. Now, when you will start your journey towards the microservices, you will probably start to think, okay, let's have several different microservices, but where will you connect them? Will you connect them to a single database? Will this database contain a single unified data model? And well, more and more experiences show that when we move to the microservices, it might also make sense to move to the database per service pattern, which means that each microservice has its own separate, independent data store. Why is this important? Because if we do microservices in such a way, then we really can parallelize the work and different groups can work independently. Those topics are quite complex, so I will just run through them. Yeah. Now, some other aspects of microservices is the deployment. Now, one of the important aspects is that we are able to deploy microservices constantly. We don't wait for all microservices of a single application to be finished. If we make a change, we change a microservice, build a new Docker container of such a microservice, and deploy it separately, without waiting for all changes to batch up and to do a complete deployment of a whole application. And in order to be able to do this, we have to provide a way that different versions of a microservice can run together. What else do we usually do when we go towards the cloud-native architectures? We automate. We automate all the things that we can automate. We automate the testing, we automate the deployment, we automate the documentation, and so on. And if you will decide to follow the cloud-native principles, actually, what I would like to also point out are the 12-factor applications. These are 12 design principles which should be followed with the cloud-native architecture. And what I have mentioned so far are the technical aspects. The other important part of the cloud-native are the organizational and the cultural change. What does this mean? This actually means that we go from silos to DevOps. And having DevOps, not only the tools, but having the DevOps culture which really works in your organization is one of the key steps towards the cloud-native architecture. The other one is to restructure your organization. in order to be able to use the full potential of the cloud-native architectures, it is also important that you restructure the organization the way how you work. Okay, last but not least, what has changed? We have seen that the cloud-native architectures actually change practically all of the steps related to software development, from architecture, from how we write code, from how we build, deploy the code, how we maintain the code, how we structure the organization, how we do the project management, and so on. It is important to understand all those concepts. It might be a little too much for this one presentation, so let me finish with this slide. The 5 stages of the cloud native. Thank you very much. I will take questions later on in the break, okay, because we are running
I think if
out of time.
Someone... Oh, later then, okay.
Thank you very much.
All day, no problem. 1, 2, 3. Me čujete? Halo? Hej. Šta? Aha, zvučnik, okej. Svi će mi pobjeći. Coffee break is in 45 minutes, not yet, guys.